Hello ladies and gentlemen, my name is Kieno Thomas and I'd like to thank you for looking at my video. This is a totally free private pilot ground school to assist you for positive reinforcement. I'm not looking to replace your instructor or your flight school or anything, but it's just some positive reinforcement. And, I'm going to have more videos to come, but this is a completely free private pilot ground school. Today we're going to talk about the 5 major components of aircraft. What are the 5 major components that make an airplane an airplane? Why do we call it an airplane? Well, there's 5 major things that we consider when we are calling an airplane an airplane. Here we have an airplane on the right, and we have some other flying mechanism on the left, but it's not classified as an airplane. Here we have an airplane on the right again, and we have a hot air balloon on the right of the screen, the airplane, and the balloon on the left of the screen. So the balloon is not an airplane. Again, on the right, it's an airplane. On the left is something else. Right again, left something else. We have a helicopter, 2 helicopters in a glider on the left, and an airplane on the right, and they climb out. So, let's talk about what are these 5 major components? Why do we care? What's the difference? Well, we have to be able to distinguish airplanes from other types of aircraft. And to jump right in, the fuselage is the main part of the airplane. Normally, it's the main part of the airplane. We have our occupants, our pilot, aircrew, cockpit, people, cargo. So the fuselage is a major part of the puzzle. Here we have another fuselage, and again, has the same characteristics. This is where the people sit. This is where the cargo is. The cockpit is up front. And it's holding all the other parts. Everything else is attached to it. So the fuselage is the major part. Even in a single engine aircraft, the cockpit, passengers, cargo all sit in that main section where the aero is. The next section is the wings, or the next component I should say is the wings, and every picture here has wings. Actually, on the bottom right, this aircraft has 3 wings. This is called a triplane. So, second component, have to have wings. On the left we have the F-14 Tomcat, and on the right we have someone in the fuselage actually pointing a camera outside and taking a picture of the wing. Here, wings. There's a biplane at the bottom, but wings are how we differentiate aircraft, or one of the ways we differentiate aircraft from every other type of craft. Not a hot air balloon, not a rotorcraft. It's an airplane. Now the next section or component we're going to talk about is the empennage. The empennage is a French word, and it means tail section. Now, up here we have a vertical and a horizontal stabilizer. All empennages are not like this. Sometimes we have a T-tail where the horizontal stabilizer is actually mounted on top or on the upper region of the vertical stabilizer, and there's some other control surfaces associated with the vertical and horizontal stabilizer, but we'll jump into that later. This aircraft is a T-tail, so it's still an empennage, it's still a tail section. The next slide we have a V-tail, V as in Victor, but it's still a tail section. Here we talked about, or we have a trim tab. This is just a picture of the trim tab and the trim wheel, how it's controlled. We'll go in depth into that later. Here we have a stabilator where this whole surface moves. We go back. Just this elevator moves, not this surface. The horizontal stabilizer stays put while this wiggles up and down. Well, in this picture, this whole surface moves up and down. And then we have something called the anti-servo tab, which we'll get into later. Landing gear. This is a conventional landing gear aircraft. We have a tail wheel or some people call it a tail dragger. We have a tail wheel in the back, and we have the main struts up front. These struts absorb shock when the aircraft is landed. The shock is actually transferred into the fuselage, so the landing gear don't take all the pain or force. Here we have a tricycle type. Notice that the little wheel is on the nose and not on the tail, so this is not considered a tail wheel aircraft. The main gear are mounted here in the fuselage, and this is a retractable gear aircraft, which means when it's not landing, the nose gear go into the body or the fuselage, and the main gear go into the body or fuselage. Here's a fixed gear where at all times when it's taxiing on the ground and when it's in flight, the landing gears stay out. You have main or spring steel struts here that absorb the shock, and then you have a nose gear landing gear. When the airplane is in flight, the wings support the weighted aircraft. When the aircraft is on the ground or taking off or landing, the main gear or landing gear support the weight of the aircraft. So you have to have landing gear. Here we have spring steel struts. We have a nose gear strut, but there's a air oil nose or air oil cylinder here. Here we have that other older construction where when this aircraft lands, the force of shock absorption absorbed into the fuselage of the aircraft. Here is a depiction or a function of the air oil nose strut. Now I'm gonna have a video, or we're gonna look at a video in a minute, but you see where the oil's down here and you have air up here. So you have all oil here, you can have a combination of air oil here. Now when the landing gear touches down, this piston is going to be pushed upward. So this piston is inside here, it's going to be pushed up. And oil is going to kind of squirt, but it's going to be very, very slow, and it's going to absorb a lot of shock in the process. And then what is going to happen is just going to readjust. So you're going to see compression, and then the piston's going to go inside, and then you're going to see a readjustment to the normal load, and it's going to come back out. Here you have an air oil nose strut. So a characteristic of what you'll see during the touchdown is you will see these arms or elbows bend. These elbows are here. You would see them bend when the aircraft touches down because this piston goes inside, just like we saw there. Now I have a video here, and up here is the air, down here is the oil, and you can just see the compression take place. So this is the aircraft landing, touching down, and then the readjustment occurs. So the piston or cylinder actually comes back out. Or a piston comes out, cylinder. I was right. This is the cylinder, this is the piston. Make sure we get our terms correct. Here's a video of an actual aircraft landing, and you can see in this video the adjustment before touchdown. It's hanging down. There's a cylinder. It's going to go in and then come back out. So now, wheels aren't the only thing that airplanes land on. Here's some water skis or pontoons. Here's some actual skis for, colder climates, snowy surfaces and things of that nature. So, landing gear. And here's these are two pictures of retractable aircraft where the wheels actually go into the fuselage for flight and reduce what we call drag, and we'll talk about that later. Another aspect of landing gears is a differential braking system, which means I can brake this wheel or brake this wheel independently, not like your car that pretty much all the wheels brake together Not so in airplanes. If we want to make a left turn, we will brake the left wheel, apply power. This brake will be off and come around, along with help from steering with the nose wheel. And if we wanted to make a right turn in this aircraft, we would apply the right brake, steer with the nose, add power, and then this side would come around. So these are the steering pedals, and this is how the aircraft is steered on the ground, or we call it taxiing. Next we have power plants. Now a power plant, we can't just think of it as an engine because it does so many other things as far as air conditioning, heating, electrical applications. So it's not just an engine. Here we have a radial engine. Here we have what we call a horizontally opposed engine. And when we call it an engine a radial engine or a horizontally opposed engine, we're speaking of the arrangement of the cylinders. We go back, the cylinders go around, these are horizontally opposed. Now, here we can see each cylinder. There's 9 cylinders in this clip. And there's 4 here, 4 cylinders in this clip. So this is a 9-cylinder engine, this is a 4-cylinder engine. And I have a couple animations here. We can actually see the radial engine at work. And we can see the propeller spinning behind. So this is a rearward look. We can see the propeller spinning, and we can see the pistons moving up and down on the cylinders, and they are actually turning this crankshaft in the middle, which rotates the propeller. Now this is a 2, 4, 6, 7-cylinder engine, and here we're going to go into it later, but we can see the actual valves moving, letting fuel and air in, and then actually kicking the burnt charge out of that fuel-air mixture. So fuel and air comes in here, the piston compresses it, spark plugs light up, and then it's pushed out. Here's a horizontally opposed engine. But we have just 2 main things out of both sides of those engines. They're turning a crankshaft attached to a propeller. So the crankshaft is in the middle, and just imagine the propeller being here, and as these pistons are moving, they're rotating a propeller. That's pretty cool. Now with the radial engine diagram, we actually saw valves moving and things happening. Okay, so for our purposes, we'll just think of it as a 4-stroke engine cycle. So there's 4 different things that take place as this crankshaft is moving around. Like I said before, this valve opens and it spits in some air and fuel. The piston is moving down. As this piston moves down, this valve closes. So these are the same. These are representative of the same actual cylinder and piston. So this valve opens, air fuel comes in, crankshaft moves around, starts to move the cylinder back up. The valve is closed, so we're compressing. Think of a balloon. We're kind of just blowing air and closing it. And then after that, what happens is a spark plug fires at a specific time, and it's almost like a boom or an explosion, so to speak. And it pushes the cylinder back down. And then it goes back up, this valve opens, and it spits out that burnt charge, or yeah, I guess burnt charge is the best way. And I'm talking about the fuel-air mixture that came in here, now was exploded, burnt, and then it's pushed out in exhaust. So we have an intake, compression, power, and exhaust cycle. Here we have turbine-powered aircraft. So unlike pistons rotating the engine, or not the engine, but the propeller, now we have a situation where turbines actually rotate the propeller, and thus turbine power plants. This this particular aircraft is called the King Air. I've flown in this airplane, and it's turbine powered. But the PT6 engine is the engine you're about to see in action. And here's a video. So we'd like to thank Aviation Nation for that demonstration or video. That was pretty cool, I thought. Our next type of turbine engines are turbofan and turbojets, and just some really basic differences between the turbojet. The turbojet was kind of like the early form of jet engines. Again, it sucks in air, compresses it, adds fuel to it, ignites it, blows it out the back. That's basically what happens with jet engines. Here we have a turbofan, and the difference between the turbojet and the turbofan, notice how we still have an intake, a compression stage, a combustion chamber where that fuel, air, just like our pistons, they take fuel and air to make things happen, and then they're exhausted out the back. But the turbofan has something really interesting going on. We still have our intake, we have a compression section, we have a power combustion section, and an exhaust section. But look here, just see how this engine allows air to flow around the outside of that chamber. Now what happens is, at the back end of this, the pressure difference actually results in increased performance and more thrust. So it's pretty cool, and it's evident that the turbofan is actually the better, more efficient engine. So that was a pretty neat depiction I found, and it helped me explain the difference between turbojet and turbofan engines. Now if we go back to our piston powered engines, both of these guys, the turbine and the piston powered aircraft, kind of sort of do the same thing to get thrust going. Kind of sort of, not exactly, but there's just different methods. Here we have intake. Here we have where the fuel air mixture is mixed, just like we would mix it here. And then ignite it, and then we get expansion, and then it's blown out the back. By expansion, as we heat the air and the fuel, there's expansion, which means the molecules spread apart, and so it's kind of like more air is blowing out the back than what's coming in, if that makes any sense. But still, we have intake, compression here, intake, compression, power, exhaust. Intake, compression, power, exhaust. The only thing is, thrust is created here, whereas the crankshaft is connected to a propeller that spins to produce thrust, kind of like a window fan. Excuse me. So to recap, there are 5 major components when it comes to classifying an airplane as an airplane. I'll put aircraft there, but just think airplane. We have a fuselage. We talked about that. Houses the cockpit, passengers, cargo, main attachment of all the parts. Wings. Planes got to have wings. Gliders have wings, but when we talk about wings, we're saying this is just one aspect of what makes an airplane. We have a tail section, or empennage. Here's the horizontal and the vertical stabilizer. Now I put this in for comic relief because somebody did not load this plane right, and it wound up on its tail. Power plants, and again, power plants are not just engines. There's electrical energy, air conditioning, all kinds of power functions. That's why we call it a power plant and not an engine. Here's a single engine. This one has 4 power plants. Landing gear. Got to be able to land. And we saw the pontoons for water and the skis for snow or icy areas. So I'd like to thank you for watching this video. If this helped you out, please like and subscribe it. Stay tuned for more videos, and be safe, and definitely fly safe. If you have any questions, comments, concerns, or anything, my email's at the bottom. Kieno Thomas, KIENO THOMAS @gmail.com, and in the subject box, please put aviation so I know that it's related to my aviation work. I do a lot of math and tutoring and various other things, so when you come in or send an email, just put a subject as far as aviation. Puts aviation in subject box. I don't know why I'm tripping over my tongue. I'd like to thank you for watching and have a great day. Bye-bye.